Hi, welcome to SolidCam. In this video we will look at multiblade machining. Multiblade machining essentially is an application-based module that is meant for generating programs for machining impellers or blisks with impellers with or without splitters. The splitters here can be as many as you want. There is no limitation on the number of splitters that can be defined in multiblade. Here we look at a classic impeller which has got a single splitter in between two main blades. So we start off with the roughing. In this case, in this particular part, we have done the roughing in two parts. First, we have used a short tool with bigger depth of cut, and that is doing almost 80% of the roughing. And then we're using a longer tool and roughing the remaining area. So the geometry that needs to be defined in this case is the blades along with the fillets that needs to be picked up. You have to pick up two sets of blade and one splitter, and you also have to pick a piece of hub. The hub surface need not be a complete surface, it just needs to be a piece of it. It can be anywhere else on the part. It need not be exactly in the same place where you picked up the blades. This is all that is needed. So if you go into the toolpath itself, we have got the geometry, which is the blade, splitters and fillets definition, the hub definition here. Then we have the tool. In this case we are using a taper ball nose tool. Okay, it's a taper ball nose, diameter 10. And in the toolpath parameters, if you go into the technology, we have a maximum distance of 10 millimeters. That means we're using a depth of cut of 10 millimeters and a side step of just 0.8 millimeter, and the 10 millimeter depth of cut is actually divided into 2.5 millimeter each. So every time it's going to go 2.5 millimeter to make the channel first and then machine the part. And towards the end in the transformation we have got rotation, so we have got 7 rotations that we need to make. So it's going to generate one program and rotate it 7 times. So I'm going to calculate this toolpath. Calculation is also very quick. So that's the toolpath that was generated. You can see here the 2.5 millimeter what I was talking about. It creates a slot of 2.5 millimeter, 2.5 millimeter depth. So if I run the simulation, this is how it's going to look like. Okay, so this is how the stock looks like, and we can start the roughing. As you can see, it starts from the center and then moves outwards. So let's switch off the holder. Again, it starts from the center and moves outwards. So it creates that slot and then expands that slot to create the roughing. That's how the splitter is getting formed. Alright, so let's move further. We have the remaining area that needs to be roughed out, and here I'm going to use a 12 diameter taper ball nose. Let's hit the calculate button, and here it is. The remaining area is being done using 12 ball nose or 12 taper ball nose. Multiblade machining also constitutes toolpaths for finishing. So you can use only the blade area and generate the toolpath for finishing. You can also generate the toolpath for splitter finishing. You could also generate the toolpath for the bottom fillet only. So you can pick up the fillets and you can finish the fillets for this blade. And also it has options to do machining for the floor. So multiblade machining is a very specialized function inside SolidCam simultaneous 5-axis machining, and it's meant for machining impellers and blisks. Thank you very much for watching this video.